Welcome back. This is video 3 on 2-5 of the Essentials of Calculus. In this video, we're going to talk about the average rate of change. You know what average rate of change is, right? It is slope. Rise over run, delta y over delta x. So we're going to talk about rate of change, and we're going to change it up for you. We've been talking about average rate of change your whole kind of schooling career. We're going to talk about instantaneous rate of change, which is more of a calculus-y idea. If calculus-y is even a word. Okay, so here we go. Rate of change. Another meaning for slope is rate of change, and we have two ways to do this. Average rate of change, right, which is what you're used to, average rate of change. This is a rock, delta y over delta x, okay? And so if a problem is asking you for average rate of change, you're going to use this formula, the slope formula or average rate of change formula. And generally, too, a kind of a way to cue in on it, and we look at this in example 13 when they ask for the average rate of change, is they'll give you 2 points, right? You have to calculate it between two values, okay? So that's average rate of change. The other topic that we're going to look at is instantaneous rate of change. And this is the slope at a single point. So instantaneous slope, right? Which before it was impossible to calculate the average, or the rate of change at one point, right? You have to have calculus. And how we do this is with the derivative, okay? So that's I rock. And again, I talked about the clue here. So if they don't say instantaneous rate of change, the clue is again that they'll give you 1 point. So let's go ahead. Let's look at a couple of these examples. For number 13, it says if f of x is equal to x cubed plus 2x, find the average rate of change from 10 to 30. So again, they'll give you x values, and what you need is your outputs. So just calculate your outputs. I plug in 10 into my function, and we get 10 cubed plus 2 times 10, and this gives us 1,020. Okay, and then we get f of 30, so 1020. Okay, and I'm going to plug in 30, so 30 cubed plus 2 times 30, and this gives us 27,060. Okay, so I found, trying to squeeze that in there, 2760. Okay, so I found my two values. So the average rate of change, a rock, is delta y over delta x, right? Rise over run. So the change in our rise is 27,060 minus 1,020 over the change in our run. So 30 minus 10. Okay, and if we plug this in, we get 1302, so 1,302. And normally we would have units, and when we look at contextual problems involving velocity, acceleration, position, so on and so forth, we'll have units to do that. Okay, so that's average rate of change. That should be prior knowledge. Now what we're going to do, we are going to look at instantaneous rate of change. So if I have the same function, x cubed plus 2x, find the instantaneous rate of change at x of 10. Well, how you calculate the instantaneous rate of change is you take the derivative. So the derivative of this function, using the power rule, is 3x squared plus 2, okay? And then they want it at this x value. So what do you think you do? Plug it in, okay? So f prime of 10 gives us 3 times 10 squared plus 2. Okay, so there you have it. This is your instantaneous rate of change at 10, okay? All right, that's it for this video. That's rate of change. Again, average rate of change, that's what you've been doing forever, right? Involving 2 points. Instantaneous rate of change, that's slope at 1 point. That's calculus. Catch you next time. Peace.